A continuous time signal x of t has a Fourier transform x of j omega equal to j omega cube divided by 1 plus omega square. Fourier transform of the signal y of t is equal to x of 1 minus t plus x of minus 1 minus t is. So, let us take x of j omega alone, okay? X of j omega alone, which is equal to j omega cube divided by 1 plus omega square, right? So, we have to use some properties of a Fourier transform over here. I'll write those properties here. Please put that in your formula book too, and also put it in your if you have a problem book, please put that in a box, okay? So, the first property of a Fourier transform that I am going to use is that x of t minus t0. Let x of t have a Fourier transform of x of j omega, and x of t minus t0 will have a Fourier transform of e raised to minus j omega t0 x of omega, okay, x of j omega. Okay, it will be multiplied by e raised to minus j omega t0, and x of t plus t0 will have a Fourier transform of e raised to plus j omega t0 x of j omega. Okay, and also x of minus t will give us x of minus j omega. Okay, so these are the properties that we are going to use here. So x of t, in this problem also x of t have a Fourier transform of x of j omega, but we have to take these two, that is x of 1 minus t. What will happen if x of 1 minus t is taken? I'm just going to rearrange it and write it in this format, okay? So that will be minus t plus 1, okay? So we'll do this this time reversal at the end. First of all, we'll write x of t plus 1. What is x of t plus 1? The Fourier transform of x of t plus 1 will be equal to e raised to j omega t0. Here t0 is 1 into x of j omega. Okay. And the next step, e raised to minus t plus 1. What happens? X of minus t is x of minus j omega. So it will be omega will turn to negative omega. On wherever omega is there, it will be turning to negative omega. So it will look like this, e raised to minus j omega. What is x of j omega? J omega cube divided by 1 plus omega square. Instead of that, we are going to take minus omega. So it will be minus j omega cube divided by 1 plus omega square. Okay. So this is the Fourier transform of x of 1 minus t. And now let's take this example. When you take this example, it will be minus 1 minus t. I'm going to rearrange it and write it in this format. It will be minus t minus 1. So I'll just take x of t minus 1. For now, it will be like this. X of t minus 1 will give us e raised to minus j omega t0. Instead of t0, we are taking minus 1. Okay, sorry, 1. And x of j omega, and it is actually minus t, right? So minus t minus 1 will be equal to e raised to j omega. Omega will be turning to minus omega. So minus of minus omega will be plus omega, and here also minus j omega. So the answer will be e raised to j omega into x of omega, x of minus omega. What is it? E minus j omega cube divided by 1 plus omega square. Okay. So we got y of t equal to, it is given in the question that 1 minus t plus x of 1 minus 1 minus t, and y of j omega will be equal to the Fourier transform of these two corresponding signals. That will be e raised to minus j omega into minus j omega cube divided by 1 plus omega square plus e raised to j omega, again minus j omega divided by 1 plus omega square. Okay. So I'll write it over here. Okay. If I am writing, I'll get y of j omega equal to e raised to minus j omega into j omega cube minus j omega cube divided by 1 plus omega square plus e raised to plus j omega minus j omega cube divided by 1 plus omega square. Here this is common, right? I'll take it outside. We'll get minus j omega cube divided by 1 plus omega square into e raised to minus j omega plus e raised to plus j omega. So what is it? Cos theta equal to e raised to j theta plus e raised to minus j theta divided by 2. So what is e raised to j theta plus e raised to minus j theta? It will be cos theta, right? So instead of theta we have omega here. So it will be like this, j omega divided by 1 plus omega square. Instead of this we will write 2 cos omega. So the final answer is minus 2j omega cube divided by 1 plus omega square into cos omega. Okay. So that is it. Now let's do the next question. Consider the signal shown in the figure below. If this signal is applied to an LTI system whose impulse response h of t is equal to u of t minus u of t minus 1, then the value of y of t at t is equal to 1.5 seconds is. Okay, so this x of t is being passed through a system with impulse response like this. So I'll draw the impulse response. How will it look like? It is u of t minus u of t minus 1. So it will be extending from 0 to 1 with a magnitude of 1. So this is actually our x of t, that is our input. So this is the impulse response of the signal of the system, LTI system. So we are going to find out how much will be y of t, that is the output of the LTI system. The output of LTI system is x of t convolution h of t, right? So this is a formula. The output of an LTI system is x of t convolution h of t. So y of t is, what is the formula for convolution? Y of t is equal to integral minus infinity to infinity x of tau h of t minus tau d tau. Okay, so this is the equation for convolution. So in the question it is asked what is y of t at t is equal to 1.5. So I am going to put it here. Y of 1.5 is equal to, wherever t is there it will be changing to 1.5. Here it is tau. Okay, so don't change it, only change t, that is 1.5 minus tau d tau. Okay, so as you can see, x of tau is being multiplied with 1.5 minus tau. Okay, sorry, h of 1.5 minus tau, that is the shifted version of h of tau is being multiplied with x of tau. Okay, so I'll take the shifted version of h of 1 minus 1.5. I'll write it like this, minus tau plus 1.5. So earlier, I'll write this minus tau plus 1.5 minus tau plus 1.5. This is a shortcut method. So this is 101, and then I have to make it to h of tau only. Then only we'll get the answer of h of minus tau plus 1.5. Okay, so to eliminate 1.5 I should subtract 1.5, right? So it will look like this. Eliminating 1.5, that means 0 will go to this side. Minus 0.5, that is 1 minus 1.5 will be minus 0.5, and 0 will be 0 minus 1.5. So it will start from minus 1.5 and end at 1.5. Okay, and now this is like h of minus tau. We have to get h of tau. Okay, h of tau will be the mirror image of this one, right? Mirror image will be like this, 0.5 to 1.5. Okay, so this is what is required. Okay, this is a shortcut method. This is how we can get these kind of shifted and scaled version easily. Okay, so I'm going to use this. I'm just going to write it like this only. Okay, minus tau plus 1.5. This is minus tau and plus 1.5 only. So this is actually multiplied with x of tau. What is x of tau? X of tau is this one. I'm just going to change the variable. Okay, instead of t we are using tau, that's all. So this is tau and sorry, x was 1, 2, right? This is multiplied with from 0.5 to 1.5, right? Okay. Now we'll see before 1.5 this is 0 and after before 0.5 this is 0 and after 1.5 also this is 0. So we can take the integral from, instead of minus infinity to infinity, we are going to take it from 0.5 to 1.5 and we will see how this is looking. This is a ramp signal, right? From 0 to 1, this is a ramp signal. From 0 to 1, this is a ramp signal with slope. What is its slope? Slope is equal to 2, right? So 2. The equation of this one from 0 to tau, 0 less than tau less than 1. 0 less than tau less than 1. Okay, 0 to 1. Okay, I'm so sorry. 0 to 1, it is having a slope of 2 and its equation is 2t. Okay. And from 1 to 2, it will have an equation. I'll write it over here, 1 to 2. Y minus y1. y1 is 2, right? It is starting from 2 is equal to m into m is decreasing slope here, which is equal to minus 2 into x minus x1. X is my tau here. Tau minus x1. What is x1? 1. Okay. So x of tau equal to minus 2 tau plus 2 plus 2. That is minus 2 tau plus 4. This is valid from where to where? 1 to 2. Okay. Now we are going to multiply this. So from this multiplication result will only be valid from 0.5 to 1.5. So I'll write like this: y of 1.5 equal to integral 0.5 to 1. Okay, 0.5 to 1, x of tau has a particular value. So we'll only take from 0.5 to 1 for now. That is, x of tau will be equal to 2t, right? 2t into 1 only. So h of tau is 1. So we are not going to write it. So d tau to tau. Okay, I'm sorry. We are taking the function as a function of tau. So again, now from 1 to 1.5, x of tau is equal to minus 2 tau plus 4 and h of tau is equal to 1 only. Okay, and now after integrating we will get the answer equal to 1.5. Please do it on your own. Okay, the next question. The impulse response of a continuous time is given by h of tau is equal to delta of t minus 1 plus delta of t minus 3. The value of the step response at t is equal to 2s. Okay, so impulse response is given here, h of tau at t minus 1 and t minus 3, that is at 1 and at 3. So this is our what? H of t. Okay, impulse response, and we have to find out the step response at t is equal to 2. So to find out the step response means the input is step signal. So x of t equal to a step signal. Okay, to find out impulse response means input is impulse response. Okay, to find out ramp response means input will be ramp. Okay, now here it is step response, that means input is now input given is a step signal. Okay, so this is 1. And now we have to find out the value of a step response at t is equal to 2 seconds. That is x of t convolution h of t. That is our y of t. Okay. So y of t equal to u of t convolution del of t minus 1 plus del of t minus 3. Opening the bracket, we get u of t convolution t minus 1 plus u of t convolution t minus 3. And now we are going to use the the property of impulse response. Okay, property of impulse response, that means if x of t is convoluted with a t minus t0, we can write it as x of t minus t0 only. That means if u of t is convoluted with del of t minus t0, the answer will be u of t minus t0, because this will have only value at 1, right? That is not the correct explanation. If you are in NISO Academy, a video is there. There is a correct explanation for convolution. So please go and watch it if you have time. So u of t convolution t minus 1. So instead of, the answer will be u of t minus 1 plus u of t minus 3. So that means u of t minus 1. How will it look like? U of t shifted to the right side by 1. And u of t minus 3 will look like this, right? And these two are added together. That is our y of t, which is equal to, up to 3 it will be 1, and from 3 it will be 2. Okay, so in the question it is asked what is value of t at t is equal to 0. Y of t is equal to 0. T is equal to 2. That is equal to, what is the value at t is equal to 2? It is 1 only. Okay, this is the first question. A system has the following output relationship: dy of t divided by dt plus 2y of t is equal to x of t plus dx of t divided by dt. The impulse response of the system is del of t minus e raised to minus at u of t, such that the value of a is. So impulse response is given here. Now I am going to use the Laplace transform over here, and as you know, d by I'll write it here. This is the answer. We are starting the answer. D by dt plus 2y of t equal to x of t plus d by dt of x of t. Okay, and I'm taking it in the Laplace domain. Then it will be d by dt will be s into y of s plus 2 into y of s equal to x of s plus here also s into x of s. And this is the impulse response, that is our h of t, which is equal to del of t minus e raised to minus at ut, and taking that in the Laplace domain, we will get Laplace transform of del of t is 1 minus 1 divided by s plus a, or s plus a minus 1 divided by s plus a. Okay, let it be like that. And the formula for h of s equal to y of s divided by x of s. From here we will find it out. Okay, so I am taking y of s outside, we will get s plus 2, and here x of s outside, I will get x plus 1, and y of s divided by x of s will give us s plus 1 divided by s plus 2. Now we will compare these two. That means s plus a equal to s plus 2. That means a equal to